Hello and welcome. Hi everybody, I'm Luke. We're here to talk about 24/7 resiliency and how we do it in the cloud. So you probably know that Google does 24/7 stuff with SRE, Site Reliability Engineers. And today we have 3 site reliability engineers from our customer and our cloud and our infrastructure. So William is here from Home Depot, and he represents our customers' SRE teams. He's actually built an SRE team at Home Depot, which is kind of amazing. I am Luke Stone. I'm from Google Customer Reliability Engineering, and I'm representing Google Cloud Platform. Here's us, okay. And Mahesh is from Google Networking Infrastructure, and so he represents the networking that underlies all of cloud and then also a lot of other Google services that rely on the same infrastructure. So what we want to tell you today is basically how we work together to make things actually reliable across all these different levels of the stack. So public cloud is a little different from your traditional on-prem environments you might be familiar with, because everything's changing all the time and you have lots of different operators going on. You can't just constrain stuff into a command and control kind of situation. So it's more about people working together. And the example we'd like to use is Home Depot's Black Friday retail event. So I want to ask William to tell us a little bit about Home Depot and your website and what you did.
Great. A little loud here. Thanks, Luke. As Luke said, I'm Senior Director of Site Reliability Engineering at Home Depot, so I'm responsible for the strategic side of reliability at Home Depot and specifically responsible for our e-commerce and order management parts of the website. Home Depot probably doesn't need a lot of explanation. I think everybody in the room probably knows who Home Depot is. We got a pretty recognizable brand. Hopefully most of you are customers. What you probably don't know about Home Depot is, though, we're a big tech shop. We have a lot of technology, point-of-sale systems, supply chain, assisted selling systems, merchandising systems, not to mention e-commerce and so forth. Just walk around one of our stores and you'll see technology deployed throughout. We have a lot of technology, especially in the retail business. Arguably, we have the most complex technology environment in retail, certainly one of the most complex. And our e-commerce part of the business, as I said, that's an area where I'm specifically working in the company, has been a big area of investment for the company. We've invested tremendously over the last 5 to 7 years in e-commerce, building out distribution centers, building out our website capabilities, building out a multi-channel retail strategy with our stores, really driving customers from online into our stores. So that is, kind of where we're coming from as a company. We have recently pivoted to a custom software development culture at Home Depot. So we're really not in every case we always make a build versus buy decision, but we've pivoted a lot to custom software development and a freedom and responsibility development culture. That's kind of the direction we've been headed, and putting a lot of investment in our e-commerce platform. And it wouldn't be a good introduction slide without a little plug to say we're hiring. I think that's kind of required for a customer to speak in one of these engagements. We are hiring. We're hiring cloud engineers. We're hiring cloud SREs. And so just wanted to call that out.
Nice. So what are you doing with your website project?
Well, I'm glad you asked. So our website, so we have gotten to this point, on a very reliable, trustworthy, monolithic platform. Our legacy platform is a monolith. Probably most people in this room have worked on that. If you're not currently, maybe thinking about moving into cloud native, sometime in your past you probably worked on a monolithic platform. So think about, despite the number of different development teams and applications you have, think about packaging those up together, deploying them together, maybe into a shared middleware. Could be, WebSphere, WebLogic, you name it, kind of the shared middleware, and you have this big iron database in the back end that only scales vertically. That's kind of what's brought us to, it's really served us very well over the years. We've done a lot of great things with that platform. but it's constraining us. It's constraining our business. It constrains not just our infrastructure. I mean, there's data scale and so forth, but it constrains our business. We have development teams that collide when they're trying to make changes and so forth. So it was very important for us to build that independence. So like many people in the industry, we embraced a microservices architecture. Been working on this for a couple years. Been chipping away at building out separate services from an e-commerce. So you might think about a cart, you might think about the search part of the platform, content, those sorts of things. So we've been kind of chipping away at that over the last several years. Actually, Ravi Yadula from the Home Depot is going to be talking about that journey tomorrow afternoon in a session where he's going to talk about Home Depot's journey to the cloud. What we're going to talk about today with Luke is the kind of operational side. So that microservices architecture brings challenges. One of the big first challenges that anybody would have and that we had was you have a lot of these little microservices where you got to be able to provision infrastructure again and again and again. That was something that was very challenging for us to do with our on-premise infrastructure. The second challenge is the fault tolerance. So in that monolithic platform I mentioned, no way to run something like that hot. No way we're going to run that out of multiple data centers. It's just the back-end database didn't support it. You can imagine the kind of database we have historically used. I mean, even hot-warm, thinking about hot-warm is still a very expensive proposition. It's not something we can easily do. And oh, by the way, also you think about Black Friday, which we'll get into a little bit here shortly. We have to provision that infrastructure well in advance, and it just sits around all the time. It's just kind of sitting there. Even with virtualization, we still have to provision that infrastructure well in advance. So,
how did that work in this year? Like when you actually had to face doing Black Friday on public cloud for the first time?
Well, the provisioning of it was, we actually, per your recommendations, we actually provisioned a little higher in the regions that we were running in just as kind of a hedge, but we did it a few days before Black Friday. And then when we got through Cyber Monday, we provisioned back down a little bit. And we didn't technically even necessarily have to do that, but we just talked about best practice. If we lost a region, then we would have sufficient capacity in another one without any blips. So,
yeah, got it. That is one of our one of our main things that we focused on when we worked with Home Depot as customer reliability engineers is we tried to say, okay, how can you get your microservices to run hot across multiple regions and zones? And this is something that we do at Google all the time because we do run globally available systems. So we have some kind of best practices and good procedures for this. And that's why we have Mahesh here to tell us a little bit about how that works for Google services. He's an expert in our global network and load balancing.
Thanks, Luke. So one of the things when we designed GCP, one of the things we wanted to ensure is try to make Google your SRE. What does this mean, right? So for instance, like we wanted to put in the infrastructure that we built. First, we wanted to make sure that it was easy to manage, so it had all the APIs to make managing it easy. We wanted to make sure that it actually managed itself a little bit as well. And we also wanted to ensure that it incorporated a lot of the best practices that we built running Google, basically the Google website and ads and Gmail over the last 15 years. That was kind of actually bread and butter when we were actually thinking about designing GCP. So what I'll do here is talk about an example of how we incorporated some of this specifically for in the load balancing product and how load balancing actually plays a part in actually providing reliability beyond just pure load balancing. Okay? So a quick recap of how load balancing works. At this basic front, the GCLB product is it takes incoming requests, okay, and then forwards the request through what looks like a proxy to a whole bunch of like essentially instance groups or backends, right? The interesting feature about like GCLB, and actually this will be interesting in how we end up managing infrastructure, is it doesn't really need DNS load balancing, right? You don't need to put a DNS load balancer in front of the load balancer. The load balancer itself takes care of both geolocation as well as balancing across your multiple instances, and you don't need to worry about that at all. And API-wise, the way this looks is you kind of set up a global forwarding rule. then which is basically an IP, and that forwards to different forms of proxies, whether it's a TCP proxy or a HTTP proxy or a HTTPS proxy, right? Which then in turn forwards to different forms of instance groups. Now, here's where it becomes interesting. The way we recommend running instance groups is basically have instance groups that span, that are actually in different clusters, that are in different zones. And this actually comes from a history of running infrastructure. Fundamentally, when you want to build a highly reliable application, really running it across multiple regions is the best way of getting reliability. It's much better than if you kind of run it across multiple zones in a region, which is definitely much more recommended than just relying on a single zone in the region, right? As an example of this, when Hurricane Matthew hit the East Coast last year, it actually passed over a US East data center, and none of you actually kind of, if you were in that region, you did not get an outage. Yes, we had taken a lot of precautions about actually kind of making sure that the building is resilient to a hurricane because it's a hurricane zone. We had ensured that there was adequate fuel. We had ensured that low priority traffic was actually routed off of the network so that if we actually had some network failures, it would still be able to carry traffic. But even then, in spite of all of that, if ever you have something which takes out a region, you expect to lose about 8 hours or so, which would mean essentially you would lose your 4 nines in like a 10-year period, right? So spreading your instances across multiple zones is definitely something that we recommend and something that really we do across the board in Google. Okay. And once you have a load balancer set up, you can actually use that for failover, right? The load balancer itself is quite tolerant of, it has some failure mechanisms that are inbuilt, right? As an example of this, when it's pointing to different instance groups in different zones, if one of those instance groups decides to be unhealthy for whatever reason, then the load balancer automatically marks that unhealthy, stops routing traffic to that, and routes traffic to everything else. Now, we can use this, again, while this is automatic behavior, this is a very useful technique to even route traffic away when you have a problem, right? When you notice a problem before the load balancer notices a problem. And we use this quite frequently to drain traffic away across multiple regions. So as an example, say you have an app that's replicated across multiple zones, and in general, say you've set it up such that you have n+1, because you are able to take any particular instance group down, but still be able to kind of actually use your capacity and not lose availability. One of the things you can do if you actually say are doing a rollout and you notice a problem with a particular zone, drain traffic away, right? Like you can basically use our API to set the capacity of that particular zone to 0, which immediately kind of starts routing, asks the load balancer to route traffic to the other zones. Now, existing connections will remain in flight. Of course, if your backends are down, those will be reset. But any new connections and any new queries will just go to the new zones. Notice that this is actually much better than if you were trying to do this with a DNS load balancer in front. Because if you were trying to do this with DNS, you would need to kind of actually, you'd be subject to DNS TTLs, right? So say you had a TTL of 5 minutes, for about 5 minutes, everybody who is trying to, till the TTL expires and your zone records change, everybody who's coming to your websites has a chance of going to the bad zone and getting issues. This philosophy actually also lines up very well with a higher level mantra that we have in SRE, which is around like essentially having an easy button whenever you actually face problems. This is, if you ever need to debug an issue in response to an outage, you're wasting about 30 minutes, really. I mean, like most people, we have either designed the system to automatically deal with problems, or if it escalates to a human and the human is actually debugging issues, you've lost 30 minutes of downtime. So typically what we do internally whenever we face any issue is the first thing you do is hit drain, right? Normally you have a zonal outage, you immediately kind of, the people actually just hit drain and continue. And we use this very regularly during our rollouts as well, right? As an example of as one operation wherein we use drains, right? So one of the things we noticed when we were doing a deep analysis of where we were getting outages from, because really, is we were getting most of our outages as a result of rollouts and config changes, right? About 70% of them were coming as a result of that. And this is, the answer, whenever you see something like that, the answer can't be stop doing it. Because if you're in IT, if you're running an organization which is thriving on change, the last thing you want to do for your business is stop making changes, right? So making changes is really an important part of the thing, but at the same time, being able to do it in a fashion which doesn't cause outages is equally important. And the ability to kind of actually move traffic away, to drain traffic away whenever you see a problem is a key part of improving your recovery time. So as an example of one of the things we do when we actually do a rollout is we typically update or push configs to a single zone. We treat our zone as a unit of failure internally. And we do A/B tests there, right? I mean, you can use a similar philosophy even you're doing a green-blue rollout. You can, or if you're upgrading parts, subparts of your zone, we do an A/B test. If you actually see any time when you have, say, your CPU load goes up or your latency goes up, just drain out of that cell. And then you can come back, figure out what's wrong, do a rollback, analyze, move forward again. This really helps improve the MTTR. As an example of this, once what happened is this is before we actually went through a lot of our things to eliminate global config pushes. There was once a config push which happened, which basically was starting to get a large number of our front ends down. It paged a person, luckily on the same floor, and the person who made that push immediately, just because he heard a noise, drained back. And that actually, in analysis, if that person had not done it and we were looking at, and we would have tried to debug it after the fact, we estimated that we would have taken about 45 minutes to debug this problem, right? So another example of having the easy button whenever you're doing changes is very powerful in both kind of actually allowing for velocity, at the same time improving reliability. But a lot of this doesn't actually, I mean, there are definitely corner cases. I don't want to paint a picture where like you just use load balancing and everything magically just works and always keeps working. There are interesting corner cases that you need to worry about whenever you're running a large-scale distributed system that spans multiple zones, right? And I'll just talk of two interesting cases. Like the first one is basically cascading failures. This is something that brought Gmail down for a little while, like very early in Gmail's history, right? The case is very simple. Like again, you just haven't capacity planned your capacity plan provision very well. You've decided to have your application across multiple zones, but you just push to a single zone, and that zone goes down. And immediately your load balancer realizes, aha, that zone is down. Let me route all the traffic to the other zones. But you've not capacity planned properly, and this is happening during a time when there's too much traffic, and that in turn brings another zone down. Now you see a problem, right? You end up bringing your entire site down. The interesting thing about situations like this is once you reach a situation like this, it's actually difficult to recover when you have users beating down on your doors to get in, right? I kind of actually casually, I occasionally try to say this. This is trying to restart an engine on an airplane when it's actually crashing. It's really hard when you're being buffeted by all the wind. And this is basically trying to do a cold start when you have hordes at your door. And one of the things we realized basically what happens is you try to bring one instance up, that comes up. Again, your load balancer says, aha, some instance is up, everybody go there. Guess what? That goes down instantaneously. You bring another instance up, that goes down instantaneously, right? We've actually, again, over time, we've worked out features and we've worked out ideas to deal with situations like this. Examples of this include load testing standard, right? Like essentially when you capacity provision, make sure you have n+1. That's the easy one. Other interesting cases are things like have degraded failure modes, wherein essentially, and this we use across of our search pages and across of static pages, right? So when you get too much load, don't try to just get rid of the more complex dynamic pages. Just serve your static page. This is something that CNN learned, I believe, in one of their postmortems. They wrote about this after the 911, when 911 happened. They actually had a traffic surge which brought their site down, and they moved to actually serving static pages. Again, an example of graceful degradation. Another thing you can do is, again, using the load balancer, you can try to black hole traffic at a single place so that you can restart your engine, start sending a little bit of traffic in there, start sending a little bit more air. Once that boots up completely, bring up the next instance, so on. Once you're able to handle that, bring up the entire site. Right? So these are all like techniques that we have learned, we've talked about. In the future, we incorporate that with our in our customer engagements, and we've written about this in our books as well. So just to summarize the key messages, the load balancer is actually a powerful reliability tool. You should use it. I mean, it's actually very useful across a variety of operations in addition to load balancing. It's very powerful. There are definitely interesting corner cases. They're definitely worthwhile talking about because, again, most people, when they run websites, it's very rare that you have a very stable traffic pattern that doesn't change day in, day out across the year. You need to really be aware of what happens at peak, what happens when an instance goes down. These are kind of things I think we actually use in our engagements with our customers, right, Luke?
Yes, exactly. So the trick is to take these, kind of gems of wisdom that SREs have developed over the years with running Google systems and try to actually apply them to our customer systems, right? Teach people how to use the technology that we have to get the most out of it. Because you don't just kind of automatically get resilience from plugging yourself into this load balancer product. You actually have to know how to operate it, and you have to be able to know how your system is going to respond behind it, right? So what we did with Home Depot is we got non-abstract with them, right? So we have a concept in SRE hiring, which is called non-abstract system design, and if anybody here has gone through an SRE interview, you know about this. Basically, we say, hey, would you like to design a system for me that's like a distributed hash table or something? And 90% of candidates kind of say, oh yeah, we'll have a hash table and it'll work, whatever. And then you kind of say, okay, well, what if it has to serve 1 million QPS, right? And now people start thinking, okay, well, what's each query? What size is it going to be? How many backends am I going to have? What bandwidth am I going to have? And you say, okay, well, what if it has to serve 1 billion QPS? And you watch how people actually apply these numbers to their specific design in order to detect failure modes and then, make a modification to the design to make it more resilient to this failure mode, right? So we do that all the time in interviewing, and the reason is because we actually have to do it all the time in real life as well. And this is what CRE is doing by bringing the wisdom and practices of SRE into our customer's environment. We take these lessons and we just apply them, right? So it kind of goes in a 3-step process. First thing we have to do is we have to go and listen and learn and figure out all about their application. Otherwise, you don't really know what your non-abstract system is that you're working with. The next thing you do have to do is you have to analyze each component of the system using numbers and figuring out what are the trade-offs and where it's going to break. And the final thing you do is design mitigations and execute them so that you can actually make a resilient system. So that's what we did at Home Depot, and I'll tell you a little bit about kind of how it went. First things first is we just went to Atlanta. This is a picture of AJ, who is one of our CRE engineers, and we're in Home Depot's store support center. Isn't that great? That gives you a little sense of the Home Depot company culture. They call their corporate headquarters the store support center. And you can see, we look out the window, and you can see a Home Depot store 121 right across the street. So we went to the store, we checked out how things are going, we walked the floor with the engineers, And we kind of see, what's their culture a little bit, the culture of this SRE team that William's building.
Yeah.
You know?
Yeah, and you guys spending the time with us there, I think we spent probably the better part of, you were there on site a couple times, but spent the better part of 3 months, I think, kind of working actively with you guys. And your engagement, one thing I actually wanted to mention, you were talking about this non-abstract system design. I've done a number of engagements over the years with other companies that have come in and done some consulting, and generally the type of consulting advice you'll get will be fairly generic architectural kind of recommendations that could be useful, tend to be more application oriented, or could be this library or that, and so forth, this monitoring and that. But what you guys did, bringing the practices that Mahesh is talking about, is the real deal. I mean, you guys are dealing with much larger systems than we're dealing with at Home Depot, but we're still big enough. And you guys are bringing pretty impressive deep understanding of resiliency and failure points and so forth that really rubbed off on Home Depot's SRE team. We actually looked at you guys as mentors, kind of helped us understand the things we should be doing. For example, a wheel of misfortune. And I interact with a lot of other people in other similar companies that aren't really tech-first companies like us. We're a retail-first. And doing something like a regular wheel of misfortune exercise, we do it weekly. This is something we learned from Google, where we set up a scenario. It could be in our stage environment, and sometimes it's in our production environment. And we kind of do the same sort of thing, where we set up a scenario, put an SRE or even a developer in front of a command line, and see how they perform. When we're done, we do a blameless postmortem, and we learn a lot from it. But that takes structure. That takes planning to do that. It doesn't happen naturally. So you don't see that very often in most enterprise environments, but it really pays off for us. So I think just you guys being around was good mentorship.
Yeah, I remember one story of a wheel of misfortune we were doing, where somebody was sitting back and saying, "Oh, that's so interesting. The traffic's not coming into zone A, but it is coming into zone B. And it's very interesting that we're losing 50% of our traffic."
Don't admire the problem.
Yeah, that's what someone said. Don't admire the problem. Hit rollback. And then I was like, okay, they're getting it. Now they're getting it. So that was cool. So we just went to Atlanta for just a couple days just to kind of get the lay of the land, right? And then we get into the meat of our CRE engagement, which is to do this thing we call an application reliability review. And it's based off of Google's internal production readiness reviews, which is what we put every Google product through before it launches to the public. And we have some specialist SREs who are really good at looking through your design docs and all your readiness procedures and identifying the gaps before you go live. And we have some of those veterans from that team on our CRE team now. And so we ran this thing. And what you do is you go through and you identify what are some of the most important components, like monitoring is always on there, deployments is always on there. As Mahesh said, like most of your problems come when you actually change something. And we did load balancing because Home Depot very impressively had set up multi-zonal and multi-regional configuration with their backends. So this procedure was led by our tech lead, Matt Brown, who happens to be an expert in load balancing and worked on Google SRE's traffic team for a number of years. And he basically met with the technical experts at Home Depot on all of these systems for a couple hours a day for several weeks, and really pick apart, how does this work? What's your procedure going to be? And we were able to, identify some failure modes that weren't covered. So, for example, if you lose a region, then you're going to instantaneously get all that region's traffic, boom, onto your remaining region, right? But the autoscaler was set to scale at 60% of CPU. So if you take that traffic and thump it over to this guy, you're going to saturate the CPU. So we're like, obviously you need to have the autoscaler set at less than 50%. That's just like one really obvious example. But we came up with a list of about 20 things, and we color-coded them. These are risks that we identified, color-coded them red, orange, and green in terms of their severity. And then we had a big meeting where we got everybody together across all the systems, both Home Depot and Google, and we kind of said, okay, here's where we are, here's all the gaps that we've identified that are major risks that we have to face before Black Friday. And we had about 6 weeks at this point to do it, right?
Yeah, and actually, I remember when Dave Renson and you first met with us, kind of pitching the idea of customer reliability engineering. One of the things you said to us was, "Hey, we're going to deep dive into your infrastructure and find some problems, and we're going to classify them, as you said, high, medium, or low." But in order for us to share fate with you, and by shared fate, what Luke and Dave were saying at the time is, "Hey, we'll be in the war room with you. We'll be in your Black Friday war room with you." But you got to pass our reliability review. So any high risk items we find, you got to remediate. So we kind of went into it knowing that that was our agreement. What I was impressed with was not only did we have action items, you guys actually had action items too.
Yeah, like, for example, we wanted to set up shared monitoring across the system so that both SRE teams, both our SRE team and Williams' SRE team, could see the same metrics on the same pane of glass. And this cuts down on the amount of confusion and, talking back and forth over support tickets. It just totally takes minutes away from any kind of response, right? So, and we took back some other feedback to the product teams, in the load balancer. Like, for example, they were intending to do a failover to a different zone by adding another instance group to the load balancer, but the load balancer takes a little while to start health checking and actually stand up the instance group. And so, even if that's your plan, then your plan includes 5 minutes of downtime, or something like that. So, so those are the kind of things we took back and forth and worked on.
Yeah, and I'll mention one other thing on the, we talk a lot about hot, and multi-region. That was actually something I was talking about the monolith earlier, and I forgot to mention it's important. One of the things, we took this golden opportunity, I mentioned we chipped away and built a microservice architecture. We built everything hot. So any customer-facing transactions we have, we actually build it to run across not just multi-regions, multi-zones in a region, but actually across multi-regions. So I think we did a lot better on your reliability review than we probably would have otherwise.
Yeah, you kind of aced it.
Yeah.
So we design SRE within Google to be a very scarce resource, and that makes the product teams value it and actually respect the recommendations that SREs are giving. Does that make sense? So we kind of said, if you want us to go in the war room with you for Black Friday, then you need to implement these recommendations as a condition. And you guys executed on it, and we worked around your production freeze, and you got all this stuff done to the point where we said, okay, yes, let's do it. So let's talk about how we prepared for the actual event.
Yep, and something like Black Friday, anybody that works in retail can appreciate how important an event like Black Friday is, or it could be. Maybe you're a marketing company or advertising company, you might have the Super Bowl, you could be in education and so forth and have your peak days. So for us in retail, it's Black Friday, Cyber Monday, even Thanksgiving. We pulled a lot of it into Thanksgiving, something we're good at. It's tried and true. We do it, been doing it for years. I've personally been doing it at Home Depot for 11 years. We start about 6 months in advance. We do regular production load testing, production destructive testing. We do a code freeze a couple weeks leading up to the event just so nothing goes wrong. War room 24/7. It's a really pretty big deal. But this year, this past year, we had our tried and true legacy platform, but we've also got very important critical services that are running in Google at that point. So it was a pretty complex year thinking about running both our on-prem platform as well as in Google. I was pretty nervous.
Yeah, I was kind of nervous too because we hadn't done this either, but I don't know. We had worked together on this as a team, and I felt responsible for the application too. And we had followed all of our SRE best practices as well as we could, so we didn't really have any reason to doubt that we were going to perform well. So we started checking the boxes in terms of, getting in a war room that has AV connectivity and real-time communications, setting up all the monitoring so that everybody can see all the monitoring, and working through, playbooks and scenarios about, what should we do if this happens, right? So we kind of worked through all this stuff, and I felt confident to put my pager on the primary on-call for it. And then we sat down on Thursday night to kind of watch the graphs and watch the watch the orders roll in. And it was pretty exciting because I really could feel that it's important to have trust in, your cloud provider. Like I could tell that you guys were giving up a lot of control from going off of your monolith, where you could, there's someone to call and yell at and fire if they screw it up, right? And it's a different deal in public cloud. So I was really working hard to win your trust so that you could, so you could go through with this proof of concept and this test on Black Friday. So, what happened?
Boredom. We have a saying in our Home Depot SRE team: if at any moment during the 5-day event or the other events we have like that, you ask yourself, why am I here? Do I really need to be here? We've achieved success. We've done what we set out to do. So it's boredom. Actually, I put a little blog post up here. When we hire somebody new into the team, we always indoctrinate them very early on about Black Friday and how important it is. And of course, we don't take vacation on Black Friday because that's a peak day. Even on Thanksgiving, many of us are working on Thanksgiving. So really kind of have scary horror stories about it. And we hired a SRE out of college who had participated in this event, and I just put his blog post here up on the screen here. It just said, all the horror stories you heard, all the wheel of misfortunes we did, all the prep we did, what was the result? Really, you just kind of sat around in a war room and watched the money come in. So that was success for us.
Yeah, I was really impressed with something that Naveen said afterwards, which was that not only did you have record traffic, record orders and revenue, and record uptime, but you also had record amount of change going into the system.
Yeah, not only just all the changes, all the microservices and whatnot, but as I mentioned, running both on our on-prem and in cloud. It was a very complex architecture this year. I think the scariest thing that happened to us that whole event was false Stackdriver alerts on Monday. That was kind of scary for a little while, but that was the worst thing to happen.
Yeah, all the pages started going off. But then, we had the monitoring set up, so we were able to, we got on Slack and we got on the monitoring and we took a look at it and we said, look, this doesn't look like it's a real problem. It's probably a false alert. And then I was able to get in touch with the Stackdriver SRE team, and they said, yeah, this is a condition that would create a false alert of the kind that you're experiencing. So I was able to pass it back. Yeah, it's a known issue, and it's just affecting the alerting. It's not affecting traffic or anything. So that worked out pretty well. There was another issue too, where there was a third-party service that was outside of both of our systems. It was just a third-party API that you were calling to, and then it was some kind of e-commerce API, and it predictably got.
Yeah, that was in our recommendations. That was actually a good example of degraded service that Mahesh talked about. It's one of the kind of the resilience concepts in your application, where we depended on a third-party service. That third-party service had a little bit of a blip. No big deal. We could just still display the relevant pages, just didn't have all the information on the page, so it was no big deal.
Yeah, we had discussed ahead of time what our SLOs were, and what services were critical services and what services were kind of okay services. I mean, I don't know what to call them, less critical. The one in question was a recommendation service, right? Like, if you like this product, you might also like these other products. So that was not critical. The main things that are critical are search, be able to find products, be able to put things in your cart and check out. So once we realized that it wasn't one of those services, we knew ahead of time that we weren't going to panic if this thing broke, because we'd already talked about our SLOs and agreed on what was critical. We were able to just kind of wait it out, and decide not to react very much to it. Yeah, it was pretty cool. So I was wondering, William, kind of how you felt that this experience impacted your project to grow an SRE team within Home Depot.
Well, the impact I mentioned earlier was kind of a good mentorship, a good role model in terms of how to think about running large-scale systems reliably. So that's actually really paid off there. And we've had a tremendous amount of success running our platform in the Google Cloud Platform. And so kind of what's next for us is continuing the migration of our platform into Google.
Nice. So what's that going to look like? And How far are you?
It's going to be busy. We're pretty far along, but we got some important things still left to do. But I'd say we're easily more than half. We're three quarters of the way through.
Yeah, I like your strategy. I think it's an effective strategy of carving off microservices kind of one at a time as you can, as you can stand up a development team to run them. And then you basically have your monolith calling out to the microservices in cloud when it's appropriate, and vice versa, right? So you basically can glue these things together with APIs, and then we can monitor at that API layer, and it's really clear what's going on. It's a pretty robust strategy to do it incrementally.
And as I mentioned, just a plug for another Home Depot session tomorrow. Ravi Adula is going to talk through that kind of the architecture. So anybody interested in kind of how we did that and kind of that journey, please attend that. The other plug is with you guys, and I didn't mention it, but at 5 o'clock we're doing the happy hour with you guys at the Fifth 9. And one of the things you'll hear from us is standardized monitoring. And so since we have all these different development teams and they're all doing different things and we're kind of driving that independence, we wanted to make sure that we standardize on the way we monitor. Otherwise, there's no way we could run all of these services in totality without some kind of standards. So we'll talk a little bit about that at the Fifth 9.
Yeah, that's one of the things that our SRE team is going to be developing over the next, several months, years. Because remember, SREs are software developers who are charged with keeping the systems reliable. So we're going to develop some software. And one of the big gaps that we see in cloud is just this ability to have a monitoring system that both sides can see. And it's like we can see the Stackdriver dashboards that you guys have created, but we can't make any sense of them, right? And anybody who has run a reasonably large system on cloud and played with a reasonably easy to use monitoring system knows that pretty quickly you get 70 dashboards, and half of them are, they're kind of, nobody cares, and you have to really be a day-to-day expert to know which ones are important, So our concept there is to work together with your SRE team, figure out which metrics are going to be our important metrics that we're going to use for SLOs and alerting, right? And then we're going to only alert on those metrics. So we don't alert if CPU goes too high, right? We alert if checkouts are not happening, right? If people are getting server errors when they're trying to put items in a cart, that's a user-facing error, and that's the type of thing we like to monitor in SRE, right? You monitor the user pain. You don't monitor a cause like CPU, because if it's not causing user pain, then who cares, right? So we agree on just a few metrics. Like I think we chose maybe 4 or 5 things. It was kind of like load balancer, traffic, errors, latency, classic SRE book stuff, and then we monitored at the storage layer, right? How slower reads basically from the storage, and then using that technique, we kind of put the whole application in somewhat of a black box, where you guys could reason about it inside the box, and we could reason about it kind of outside the box. And it was a nice tight contract that we had between our two teams about when we would alert each other. That was cool.